Here's problem 718. When a crate of mass m is dragged a distance d along a surface with coefficient of kinetic friction mu sub k, then dragged back along the same path to its original position, the work done by friction is... We might think that this is similar to the last problem, but there are some notable differences. And even though we return back to our original position, this is what's happening. As we pull this along with some force F, friction is going to work against that force. So the frictional force is always working against us as we give it some positive displacement. So our first work done by friction, it's called WF1, is equal to the frictional force dotted with the displacement, which is going to be the frictional force D, and there's going to be a 180 degrees angle between the two. So as we finish this, this will be cosine 180 degrees. Cosine of 180 is a -1, so this is going to be a negative frictional force times distance. Since the frictional force will be mu times the normal force, mg in this case, this is going to be negative mu mg times distance, at least for the first leg. Then as we return, still pulling on this, friction will again work against the motion, and our displacement will be in the direction that we're pulling. So there again will be 180 degrees difference between these two vectors. So the work done by friction on the return trip is frictional force times dotted with displacement, Fd cosine 180 degrees. Again, cosine of 180 degrees is a -1, so this is a negative frictional force times distance, which would be a negative mu mg d again. So our total work done is going to be the sum of these two, F1 plus work F2, which is going to be a negative mu mg d plus a negative mu mg d, which would be a -2 mu mg d. So it's not 0, because the work by friction is always going to be negative in this case. Now the net work done on the block will be 0, because the blue force F that we're pulling with is doing positive work, and that positive work will be exactly equal to the negative work done against it by friction, giving us a net work done of 0. But the work done specifically by the force of friction is a -2 mu mg d.